determine the number of moles of oxygen in 7.20 moles of H2SO4, which is sulfuric acid. So what I want you to do now is look at this formula, which is H2SO4, look at the periodic table that you have, and tell me what the molar mass of this is. What is the molar mass of H2SO4? So take your calculators out, spend some time doing this. So as we know, we're asked for the moles of oxygen, and we're given moles of, oh, I don't think we actually needed to find the molar mass. We are given the moles of sulfuric acid. So if you go over here, you are given moles. So here's a chemical formula, H2SO4, 1 mole of water has 2 moles of hydrogen, right? So within a chemical formula, you can find the moles or grams of any of those things. So let's actually go ahead and do it for this question. So I'm going to give you a minute to see if you're able to solve it. In 1 mole of H2SO4, how many moles of oxygen is present? That is one of the ratios you will be using. In 1 mole of H2SO4, you have 4 moles of oxygen. So with this information, we can now go ahead and solve this question. You're going to start with 7.20 moles of H2SO4. And then we say that in 1 mole of H2SO4, we have 4 moles of oxygen. And that's pretty much it. And when you solve this, you will get the answer. So it's 7.2 times 4. Does anybody have questions about this problem based on the answers you have over here? Or did you get something else as your answer? So let's actually go back to our chapter 6. And what we will be doing now is a couple of different things. We'll be doing percentages, 2 topics, percentages, and the next topic we're going to do is empirical formula. So let me actually go ahead and kind of tell you what the definition is. So for example, if you got 20 out of 25 on an exam, what percent do you think you got on that exam? So that's a B, but what would it would be 80%, right? So you're pretty much doing 20 divided by 25 times 100. So let me actually go ahead and look at this whole percentage. So what you are doing is, when we are talking about percent is, so when I say that you got 20 out of 25 and what your total percent is, you're saying, well, 20 is what I got, 25 is the total amount, right? 25 is the most it can be, and then you multiply it by 100 to see what that would be out of 100. And if you solve this out, you get 80, and we say 80%, and this percent sign means out of 100, that's what you got. So we're doing the same thing. This topic is called percent composition. And what that means is, if there's a compound like, C2H, something like that, or we can say, well, what's the amount of carbon in this compound? Then we can say, well, we have 2, carbons, and the total thing is C2H8, something like that. Or if you were asked something, let's look at this question. This is a really good example. So when you are finding mass percent of an element X, so this compound would be mass of X in a sample divided by mass of the total compound. So an example over here is, suppose you 0.358 gram of chromium reacts with oxygen to form these many grams of metal oxide. Calculate the mass of chromium. So we're given some reaction. We don't know exactly what the chromium is. Is it chromium 2 plus, 1 plus? Nothing we know. We just know that you had chromium and then you had oxygen and you form some compound with chromium and oxygen. This is not the right formula. So I'm just writing what we've been given so far. The other information besides that we have been given is the chromium is 0.358 grams. And we don't know how much the oxygen is, but it forms 0.523 grams of this compound, right? So that's what we have been given. And we're asked, what's the mass percent of chromium? So in this compound, what is the percentage of chromium in it? So just like this, if this is, 25 and your chromium is 20, what's the percent of it? So instead of 25, the amount we have is 0.523 grams and chromium is 0.358 out of that. So if you were to write given to find, you would write, well, we're given mass of chromium is equal to 0.358 grams. And the second thing we're given is mass of chromium oxide is 0.523 grams. So, and this is the formula. If you have to find mass of one thing, mass of that divided by the total sample times 100. So go ahead and solve this question. So to solve this question, you probably just went ahead and did, mass of chromium. So that is 0.358 grams, which is just the mass of chromium over the total mass. So 0.523 grams, and you did times 100. And you should get your answer as around 68.5. So that is the answer to this question. Does anyone have questions about how this problem is solved? Okay, so let's go on to another question. This is question number 2 in the exercise. So determine the mass of titanium in 57.2 grams of titanium oxide. The mass percent of titanium is 59.9%. So look at this question carefully and see what information is given to you and what are they asking you to find. All right, so in this particular question, based on what we are given in this equation, we're actually asked to find the mass over here, mass of our titanium. We're given the percentage, 59.9%. We're given the total mass of the sample also. So we have to find this particular thing. So in this equation, if you were to put things in, this is given to us as 59.9%. This amount is given to us as 57.2 grams. So it is, you have to kind of manipulate it to get your X, or the amount of titanium. Now, as you're doing it, remember 59.9, it's a percent. That means it's divided by 100. So it's 59.9 divided by 100 is equal to X divided by 57.2. Then move things around and you should get. So in this particular case, we're going to get our X, which is equal to titanium is equal to 34.26 grams. Is there anybody who got something else as the answer for this? So this question is very similar to, I got 80% and the total was out of 25. So how many points did I actually get? Now we'll actually move on to another question where we will look into the whole moles. So what's the mass percentage of chlorine in this particular compound, the formula for that is C2Cl4F2. C2Cl4F2. So we're asked how much chlorine is in this. What's the amount of chlorine in it? So look at this question for a moment and think about what information you might need, what relationships you may need. And if you had to go about solving it, how would you solve it? So is there any relationship you think we may need for this question? So to solve this question, this is how you are going to start. Again, we are going to do mass of our sample in the compound. So if you go ahead and look here, we actually have 4 chlorines. So we have to write the mass of it. So over here, we will write, 4 chlorines, whatever their mass is from the periodic table. Over here, we will write the mass of this compound over here, and then we will times it by 100. So we will need the periodic table to find the mass of it. So for chlorine is 35.5 from the periodic table. Here's periodic table 35.5 grams, and then 4 times that. And then we're going to do it for the rest of it. So at least mass percent is equal to 4 times chlorine over whatever the molar mass for this is, C2Cl4F2. So go ahead and use your calculators to find this mass. So 4 times 3.5 is going to be about 141.8 grams for chlorine on the top, times the mass for the compound. So go ahead and find that, and then you multiply it by 100. So carbon is around 12. We have 2 carbons, so 12 times 2 plus 4 times chlorine. And then in this one, we had 2 fluorines. So fluorine is here, 18.9, and fluorine, chlorine, and carbon. So we have to multiply all of them to find the molar mass for this compound. So you should find it as around 203, 204. So your total answer ends up becoming around 69.58%. So one of the relationships you used over here is that there are 4 moles of chlorine in this compound. So when it's asking you specifically about chlorine, that is one of the relationships you've used.
So when we do it like this, are we doing any figs like?
So if your periodic table has, it'll depend on what you have over here. So if you have 4 sig figs and you're just doing a multiplication or division, that's what you're going to write. Your final answer should have 4 sig figs.
Okay, thank you.
So this is the one topic we were going to cover today, which is mass percent. So you've probably used this before, but this was specifically for what we're doing today, various elements.